All right, so if you're watching this video, it means that you are having a difficult time with tables and probability. So I'm going to start with the most simple questions, and then I'm going to get more complicated. All right, I actually pulled this from your book. So this was a chart. You'll see it is split up by age. And then the question was, like, who do you want to be the first lady? OK, like, this is old. So this was, like, Hillary Clinton, and then, like, I think it's Laura Bush. OK, are the names. And then we have the people who were like, I don't care, or they're the same. So the first question says, what is the probability that, I should say a person, like a person I choose at random, thought Bush fit their first lady ideal? So basically, what's the probability that I choose a person who has selected Bush? Well, I don't know anything else about them other than they picked Bush. So there are 518 of those out of the total. I don't know anything about them, so they picked Bush. I don't even care what age they're in. Just there are 518 of them. The next question says, what is the probability that a person is younger than 50 years old? So if I choose one of these people out of the whole chart, I want them to be under 50. Let's see. Put this in a different color. These people are under 50. So are these ones. So let's see. All together, I have 217 plus 416. Out of, again, my total. Like, I don't know anything about them, so I'm out of everybody. And of course, like, I'd add this together. Like, I don't know. I don't have my calculator here. Forgive my terrible math. I'm doing this kind of last minute for you guys. So I got 633. And of course, you can plug these in your calculator and get some decimal approximations. That's great. Let's do one more. See if I can get this all to fit. What is the probability that the person is younger than 50 and thinks Clinton best fits their ideal? Ooh, OK. So I'm going to move this to a different color. So they have to be under 50. I don't know why green's not working. There we go. And they have to have clicked Clinton. So I'm looking at these people on the Clinton row. OK. So there's 135 of them and 158 of them out of, well, everybody. So again, like, I'd actually add those together. Hopefully you're checking my arithmetic here. And again, I can type that in the calculator and get a decimal approximation. That's great. So hopefully you're seeing, we're just trying to find the spots we need on the table. OK, but then we're going to change things up a little bit. Same table, same story, but now I have this among the 18 to 29-year-olds. So all of a sudden, I'm saying, I know somebody is 18 to 29. So before I even answer the question, I'm going to, like, zoom in on 18 to 29. The rest of this table doesn't even matter to me anymore. Like, it's gone. I only care about the 18 to 29-year-olds. So what is the probability that a person responded Clinton? Well, here's the people that responded Clinton. Out of, notice, this is my total. I'm not using this anymore. That's everybody. But now I only care about the everybody that's 18 to 29. All right? Ooh, OK, let's try another one like that. Whoops. Moved my table instead of erasing my drawings here. All right, so in the next question, we have, what is the probability that a person who chose Clinton is between 18 and 29? What? That's not the same question? No, it's not. What's the probability that a person who chose Clinton? So I already know that this person chose Clinton. So now if I'm going to, like, zoom in on the universe, I only look at people that picked Clinton. OK, so none of this matters anymore. I only focus in on the people who chose Clinton. And I want to know what's the chance they're between the 18 and 29. Well, here's the 18 to 29s. There are 135 of them out of the 437 that picked Clinton. I can't tell you what else to do other than read your questions carefully so that you do the correct conditional. By the way, this is probability of 18 to 29 given that they chose Clinton. So the thing I already know is what I zoomed in on. This first one was, what's the probability they chose Clinton given their 18 to 29? So hopefully that helps to see that the problems are actually different. Okay. All right, I'm going to cover two last topics. Are choosing Clinton and being 18 to 29, are those disjoint? Remember, disjoint means our Venn diagram would look like this. So when I think about people who voted for, wanted Clinton, according to this survey, here's people that think Clinton's a good idea. Again, we're talking first ladies. And then I have the people who are 18 to 29. I actually drew it this way because there are some people who are both. As a matter of fact, like they're right here. These people are 18 to 29 and they voted for Clinton. So the question might be, sorry for correct grammar, are they disjoint? That means, do they look like this? No, because we include a reason. You can want Clinton and be 18 to 29. So if you can do both at the same time, the answer is no, they are not disjoint. By the way, being 18 to 29 and being 30 to 49, those are disjoint. You can't be both at the same time. All right, one more. Picking Clinton and being 18 to 29, are they independent? That is a completely different question. We verify independence with this definition. I keep harping you back to it like I'm like broken record. Okay, use this, use this, use this, use this. It's not on your formula sheet. You just need to know it. Okay, and I kind of put a question mark here. I'm not sure if they're equal. So I try it out. Instead of B's and A's, I put in the two things I'm talking about. And I don't care which one is B and which one is A. You choose. I don't care. I'm going to put B as choosing Clinton. Why? I don't know. Just because it was the first thing I saw. So probability we choose Clinton given we're 18 to 29. Is that the same as the probability of choosing, notice B is the first one, so this needs to be Clinton? I actually haven't answered the question yet. I need to fill in some numbers. So what's the probability somebody chooses Clinton given they're 18 to 29? Well, given they're 18 to 29, they've chosen Clinton. This is 135 out of 217. Is that equal to just choosing Clinton? I'm going to do this in a different color. Well, here's all the people that chose Clinton. Notice, probability of Clinton. It doesn't say given, so we're just in general. There's 437 out of 1,005. That was my total. Now, I don't have a calculator in front of me. Again, I told you I'm kind of doing this on the fly to help you out. But, I type those in my calculator and double check, but I just have a sneaking suspicion those two things are not equal. If they are not equal, then the answer is that choosing Clinton and being 18 to 29 are not independent. Not equal, not independent. Not equal, not independent. Okay, watch it again. Watch it again. Watch it again until you get what I'm doing. If you still have watched it 3 times, come see me. All right, good luck.